Jai Hind everyone. My name is Dr. Parul Verma. I am Assistant Professor in Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to deliver lecture on liquid crystals. This is the topic of the subject Engineering Chemistry, whose code is KS102T and KS202T in even semester. So let's start the topic liquid crystal. So what we are going to cover in this topic: definition, types of liquid crystal, properties of liquid crystal, and application of liquid crystal. Now coming to the point, what is liquid crystal? So as we all know, it is a fourth state of matter. Before discussing liquid crystal, let us look into what are other three phases. So these three phases are solid phase, liquid phase, and gaseous phase. You are well aware of the fact that solid phase is the most important phase in chemistry, in which the molecules are oriented, molecules have orientational order as well as positional order. Why it is having orientational order and positional order? Because molecules are having very strong intermolecular forces. They have, these strong intermolecular forces held together and they form a strong bond between the molecules and molecules. Due to this strong intermolecular forces, the molecules are aligning themselves in a proper orientation as well as they have fixed position. Coming to liquid phase is the state of matter which does not have any orientation as well as position order. The molecules are randomly distributed. They take a shape of container and very less intermolecular forces in between. They have very less intermolecular forces in between. They are randomly arranged, and when we come to gaseous phase, there is no proper ordering, no proper orientational order as well as no positional order. So when we look into three phases, the common difference between all these three phases are that solid phase have both orientational order as well as positional order. Liquid phase does not have any orientational order as well as position order. Gaseous phase also does not have any positional order and orientational order. So coming to our topic, which is liquid crystal phase. So what do you mean by the term liquid crystal? It means a substance which is having the property of liquid as well as the property of crystal. So thinking about that, what is the main property of liquid and what is the main property of crystal? So when we are thinking about these properties, we can say the liquid crystal is a phase. It is a phase in which liquid crystal flows like liquid. It flows like liquid. It has mobility and it will take the shape of its container. But it differs from liquid as well as it looks like liquid. They are having a random arrangement like liquid. But why we are saying it liquid crystal? What is the property which it is having like crystal? It is having some sort of orientational order like crystal. That's why this is a phase which is known as liquid crystal, having the property of mobility as well as the property of solid. So which property of solid it contains? Actually, it is having a orientational order. The molecules present in this phase are oriented in some direction. We can see that in liquid there is no orientational order. So if we see there is no orientational order. Orientational order in liquid is 0, we can say, and it is perfect in solid, while in liquid crystal it is having some degree of orientational order. So first discovered liquid crystal is cholesterol derivative. Cholesterol derivative is discovered, which is known as liquid crystal. Now I am going to explain more about liquid crystal. Liquid crystal are the substances that exhibit a phase of matter that has properties between those of conventional liquid and of solid crystal. Now think about what are the property of a conventional liquid. The liquid is having mobility. So we can say very easily that mobility, the liquid is having mobility. So we can say that our liquid crystal are going to mobile. The molecules present in a liquid crystal are very much mobile in nature. And what is the main property of solid? The most important property of solid is anisotropy. So we can say that in this liquid crystal, some anisotropy is there. So they are like liquid as well as they are like solid. So when we are going to explain types of liquid crystal, we divide liquid crystal, we classify liquid crystal on the basis of its mobility as well as on the basis of anisotropy, because it is having both. Some degree of mobility it is having and some degree of anisotropy it is having. Now coming to another point, how we came to know that this substance, this phase is actually a liquid crystal. How we came to know? Because the substances, some solid, undergo two sharp phase transformation. They first fuse sharply to form turbid liquid, not random liquid, but they form turbid liquid, the liquid which are turbid in nature, thick in nature. The molecules are not randomly arranged as like in liquid, and then they again sharply change their phase at very high temperature and convert into clear liquid. So we can say when solid at some transition temperature converts into turbid liquid, it is known as liquid crystal. Then it converts into liquid at very high temperature, again a transition temperature came. So the molecules, the structure, the phase which is having two transition temperatures, are known as liquid crystal. So you can see that example, cholesterol maestrate. So this is the molecule of cholesterol derivative. It is a cholesterol derivative in which solid converts into liquid crystal at 71 degrees centigrade and liquid crystal converted into liquid at 85 degrees centigrade. So from going from solid to liquid, when two transition temperature, when clear two transition temperature came during this transformation, it is known as liquid crystal. Definitely a liquid crystalline state has been formed in between. Now coming to the point which is a very important aspect of liquid crystal, that is orientational order. So if we assume that all molecules are oriented, what does it mean? It means that all molecules are directed towards something. So wherever it is directed, if we look into this diagram, all molecules are, average number of molecules are oriented like this. So when we assume that there is a line, we represent this orientation by arrow. This arrow is known as director of LCs. So this is the property of LCs, liquid crystal, that in liquid crystal, some orientation we can observe. Most of the molecule, an average number of molecule are oriented in a similar manner, We can even calculate the angle theta at which average number of molecules are oriented. So orientational order is the important property of liquid crystal, due to which we can say that the molecule is actually a liquid crystal rather than liquid or rather than solid, because it does not have perfect orientational order and it does not have perfect randomness like liquid. So it is in between phase of solid and liquid. That's why this phase is also known as mesophase, where meso means intermediate, and this phase is also known as mesogenic phase. Mesogenic phase, where meso means intermediate. So orientational order is the very important property of liquid crystal. Now coming to another point, another aspect is, are all molecules is able to find this liquid crystalline state? No. Only few molecules are able to form this liquid crystalline state. What are these? What are these properties? First one is that molecule must be long, elongated in shape length should be significantly greater than its width. So whenever the molecule is elongated, long elongated organic molecule actually have a capability to form liquid crystalline state. Another one property, these elongated molecule have some rigidity in its center region and the ends are somewhat flexible. So the molecule must be elongated in nature. We can say the molecule must have some rigidity in the center and the molecules are somewhat flexible. These three main properties are there. Other properties are presence of conjugation. Most of the liquid crystal molecules have conjugation in it. So we can say the long elongated molecule having conjugation. In organic chemistry, there are so much molecules which is having a long elongated structure and also the conjugation are able to show liquid crystalline state during phase transformation. And presence of polarity is another problem. Another reason to show liquid crystal. So these are the properties due to which a solid can convert into liquid crystalline state. If the solid lack these kind of properties, it means it is not able to form liquid crystal, although it converts into liquid randomly. Now, we can see some examples of long elongated organic molecule in which center region is somewhat rigid in this structure because of C double bond N, in this structure because of C single bond N, in this structure because of N double bond N. So some rigidity is there in the structure. While flexible and functional group are present, flexible functional group are present in corner of the molecule. And one more important thing is there that all these molecules possess very strong dipole moment. Due to this strong dipole moment, the molecule get attracted with each other. And before transforming to liquid, they actually converted into liquid crystalline state first. And when more temperature is given, when more solvent is added, they are going to convert into liquid. Now, another important aspect of liquid crystalline state to show that whether liquid crystalline state is formed or not, to show that if liquid crystalline state is formed, how we can prove that liquid crystalline state is formed. So this is the method that we can draw phase diagram of liquid crystal. Phase diagram, what is phase diagram? Phase diagram is actually pressure temperature curve of system. So if we make a pressure temperature curve of liquid crystal, we can observe it is having two triple point. Unlike another system such as water system is only having one triple point which represent that solid, liquid and vapor. What do you mean by triple point? Triple point is the point where solid is in equilibrium with liquid and it is in equilibrium with vapor. And what does it mean that it is having two triple point? It means we can say here solid is in equilibrium with liquid crystal and liquid crystal is in equilibrium with liquid, and we can say liquid crystal is in equilibrium with liquid and liquid is in equilibrium with gas. So such system in which two triple point can be observed means there is a formation of some mesophase which is known as liquid crystal. Why it is so? Why it is showing two triple point? Because if one triple point is there, not all four phases can be in equilibrium in one triple point, all four phases. Only three phases can be in equilibrium in case of one triple point for single component system. Now coming to classification of liquid crystal. So there are two major classes of liquid crystal. One is thermotropic liquid crystal, another one is lyotropic liquid crystal. But first we discuss thermotropic liquid crystal, then we discuss lyotropic liquid crystal. So coming to thermotropic liquid crystal, one by one I am going to explain all the points of thermotropic liquid crystal. LC phase transition resulted from temperature changes. How thermotropic liquid crystals are formed? Thermotropic liquid crystals are formed by intervention of some temperature. By intervention of some temperature. So, few degree of temperature, some temperature is given, some heat is provided, then it is going to form liquid crystal. So, we can say that thermotropic liquid crystal can be obtained by intervention of temperature. So, when we introduce heat, when we introduce temperature, thermotropic liquid crystals are formed. First thermotropic liquid crystal which has been observed is actually cholesterol benzoate by a biologist who is Frederick Renitizer. So, here cholesterol benzoate at 145.5 degrees centigrade converts into liquid crystals, and when heated up to 178.5 degrees centigrade convert into liquid. So, we can observe that when cholesterol benzoate shows the formation of liquid crystal by intervening the temperature. If we intervene the temperature, they first convert into liquid crystal, and when we intervene the another temperature, more temperature, higher temperature, it converts into liquid. So, whenever the intervention of temperature results into liquid crystal, it is known as thermotropic, because you all know that thermal means heat. Now, different type of liquid crystal, different type of thermotropic liquid crystal. The first one is pneumatic liquid crystal. What does pneumatic means? In Greek, pneumatic means thread. Pneuma means thread. So, it is thread-like liquid crystal. What are the properties of these pneumatic liquid crystal? It does not have any positional order and possesses orientational order. Some degree of orientational order it is possessing. The molecules are elongated in a rod-like shape and are thread-like. The molecules are free to flow like liquid. In pneumatic liquid crystal, there is very random movement. There is some mobility, some degree of mobility. So, we can say it is just like liquid. But no, they are not liquid because they maintain their long range directional order. Because they maintain their long range directional order. So, they are like liquid, but although instead of having this randomness, they also have some long range directional order. They does not have layered structure like liquid. They have very low viscosity. They formed at relatively high temperature and can be aligned in the presence of electric or magnetic field, hence useful as display system. The example is para-azoxyanisole. So, what do you mean by pneumatic liquid crystal actually? It is more like liquid. These are more like liquid and less similar to solid. So, if we compare liquid crystal, that is pneumatic liquid crystal, to liquid, it is more like liquid. But when we compare pneumatic liquid crystal to solid, it is less like solid. It shows more properties of liquid and less properties of solid. Next phase is symmetric phase. So, you can observe these are the phases which is having some degree of positional order, like solid we can observe, but these are not solid because in these molecules are actually moving within the layer. So, these molecules are actually moving within the layer. So, what does symmetric means? Symmetric means soap-like. So, beside orientational, there is also some positional order present in this phase. They are soap-like, clayey or greasy. Symmetric A to K phase have been discovered, but among these all phases, symmetric A and symmetric C phase are properly known. So, you can observe on the slide that this is known as symmetric A phase, which is more like pneumatic, and this is symmetric C, which is more like solid. So, in symmetric C, the molecules are tilted away from the plane, and in symmetric A, the molecules are properly perpendicular to the plane. So symmetric means soap-like molecule. The symmetric phases are, if we compare symmetric liquid crystal to pneumatic liquid crystal, we found some differences. What are these differences? Symmetric are found at lower temperature, form well-defined layers that can slide over one another in a manner similar to that of soap, which is completely absent in case of pneumatic liquid crystal. Not affected by external electric or magnetic field. You have seen that pneumatic liquid crystal get aligned in the presence of external electric field and magnetic field. They have high viscosity, while pneumatic liquid crystal have less viscous, more like liquid. These phases are liquid-like within the layer. So they show movement within the layer. But if we observe the whole crystal from outside, you can see that it is just like solid, but it is not solid. It is the layer, the molecule in the layer are actually moving. Different symmetric phases, all characterized by different types and degree of positional and orientational order. It means the variety of symmetric liquid crystal have been formed, as I just said, A to K. So A is having some other degree of orientational order, some other degree of positional order. K is having some other degree of positional order. The example of symmetric liquid crystal is ethyl para hydroxyphenol. So we can differentiate between, this is a very important question, difference between pneumatic and symmetric, because both are the type, comes under category of thermotropic liquid crystal, and they are thermotropic liquid crystal, but they are different. Symmetric liquid crystals, symmetric LCs are more like solid. Symmetric liquid crystals are more like solid. Now coming to third type of thermotropic liquid crystal, which is known as Cholesteric liquid crystal. In this, molecules are having high intermolecular forces which favor alignment between molecules, and molecules in each layer, the molecules are at slight angle to another. In this type of crystals, in each layer, the director is not fixed. The second layer is having another type of director. It means the theta degree is different. It is not fixed. Director is not fixed. In chiral pneumatic phase, the chiral pneumatic phase actually exhibit chirality. That's why this is also known as chiral pneumatic phase. So you can see this is the structure of chiral pneumatic liquid crystal, where you can observe that the molecules are oriented in some direction. Molecules are oriented in some direction and show some movement. Each and every layer shows some movement. And after few rotation, it shows the similar appearance. After few rotation, it shows a similar appearance. These are the helical-like structure. They show the similar appearance. The structure in which the molecule shows similar appearance, this length in which some of the layers are getting arranged and form a similar appearance, it is known as P by 2. And when the molecule show the exactly same appearance, like this, exactly same away, one more half, it is known as P, pitch length. So what we are saying, that if the director rotates about a horizontal axis, the distance of one full rotation is called as pitch length, which is the very important property of chiral pneumatic phase. So in Cholesteric liquid crystal, you can see that there are some layers arranged. These layers are actually pneumatic-like layer, pneumatic liquid crystal-like layer. Each and every pneumatic phase is having molecule which is fixed some orientational order. Another layer have different orientational order, different angle. Another layer have different angle. And after few layer getting arranged, it is having one similar appearance. And after another few layer when arranged, it is having the same appearance to the first layer. So the rotation of these layer, the angle by which it is rotated, and after 360 degree of rotation, one full rotation is formed, which is known as pitch length. So the number of layer which are arranged to form a chiral nematic liquid crystal is different. So if the second layer is tilted by 10 degree, so you can see 360 divided by 10, total 36 layer are arranged to obtain the similar appearance. And if the second layer is suppose tilted by 20 degree, so you can observe 360 divided by 20 is equal to 18. Total 18 layers are getting arranged to get the similar appearance. So if 16 layers are arranged to get the similar same appearance, if 16 layers are arranged to get the similar appearance, the pitch length is less. If 36 layers are arranged to get the similar appearance, same appearance, the pitch length is more. So this pitch length is important criteria to observe the properties of chiral nematic liquid crystal. And what are these important properties? These important properties are that according to pitch length, the light can be reflected. The light can be reflected. How the chiral liquid crystal reflects light? It reflects when the light wavelength, the wavelength of the light is equal to the pitch length. So which light is this chiral liquid crystal is going to reflect is actually the length of pitch in a particular liquid crystal, chiral liquid crystal. So chiral liquid crystal shows a very good phenomena of reflecting light, and if the wavelength of light changes, the reflection obviously changes, and it is totally depending upon the pitch length. So if pitch length is more, the more wavelength light is actually going to reflect. If pitch length is less, the less wavelength light is going to reflect. But these all comes under visible light category, 400 to 700 nanometers. So we can observe these colors. You know that the color of the light according to their wavelength, different color of light is there in the spectrum. So according to the pitch length, a specific wavelength of light, a specific light of a specific wavelength is getting reflected from the system, and you can observe it, you can draw the pattern out of it. Another important point in case of chiral liquid crystal is that this pitch length is temperature dependence. That if we can say that this pitch length is inversely proportional to temperature or is inversely proportional to another criteria such as viscosity, surface tension. So how? If temperature rises, the molecule start moving. Molecules are getting energy, and when the molecules are getting energy, they easily get rotate. So when these molecules are showing rotation, easily we will get the pitch length. The size of the one layer between the interlayer distance is getting less by increasing the temperature, because actually the molecules are moving very fast. So if we rise the temperature, pitch length decreases. So it is very useful in detecting the rise in temperature over the places. Wherever the temperature phenomena is there, we can use chiral nematic liquid crystals. So these are some examples in which one transition point is there, that is known as SC, that is symmetric C. Another transition point is there, which is known as nematic liquid crystal. So these are some molecules which show both the phases, symmetric as well as nematic. So you can see that solid can be converted into symmetric C. Symmetric C can be converted into symmetric A. Symmetric A can be converted into nematic, and nematic can be converted into liquid. So what does it mean? That over the change of temperature, by the change of temperature, on rising the temperature, as temperature increases, the solid can be converted into symmetric C, then it is converted into symmetric A, then it is converted into nematic, then it is converted into liquid. So by this phenomena, you can observe that all the phases from solid to liquid must have different degree of orientational order as well as different degree of positional order. The phase which is more closer to solid show more position order. The phase which is more closer to liquid show more orientational order, or we can say less degree of positional order. So now we are moving towards lyotropic liquid crystal. Here the name suggests lyo means solvent, lyo means solvent, solvent. These liquid crystals are formed by mixing solvent in the solute particle. So when we mix solid into some solvent and the concentration of solvent is like that it forms liquid crystal rather than liquid. So by the intervention of solvent, if liquid crystals are formed, then it is known as lyotropic liquid crystal. So usually when two different substances are mixed together and they are in the phase which is having liquid crystal like property, it means it does not have fixed structure like solid and it does not have mobility like liquid, then it is known as lyotropic liquid crystal. Here the intervening system is solvent, while in other, that is thermotropic liquid crystal, we are obtaining liquid crystal by intervention of temperature. In these type of liquid crystal, we can observe that whenever the molecule has two ends, one is hydrophobic in nature and another one is hydrophilic in nature, then only the molecule can show lyotropic liquid crystal like properties. So lyotropic liquid crystal are the liquid crystal which we can obtain by maintaining concentration of solvent, maintaining minimum concentration of solvent. In these type of liquid crystal, we can observe that by increasing concentration of solvent, various phases can be obtained, among which discontinuous cubic phase is there, hexagonal phase is there, lamellar phase is there, bicontinuous cubic phase is there, reverse hexagonal and inverse cubic phase. So by increasing the solvent concentration, when these liquid crystals are clubbed together, they will form a structure which is known as lyotropic liquid crystal. So here one can observe that these chains are non-polar in nature, while these heads are polar in nature. So earlier you have studied this phenomena in missile formation. So whenever missiles are formed, it is a cluster of an organic compound. It is a cluster of an organic compound in which polar solvent arrange medium with reference to its sign. So if here is the organic molecule which is having negative end, like a soap molecule C17H35 COO Na. This molecule is dissociated into two parts, C17H35 COO negative and Na is positive. So if here is positive sign, it will club with negative sign of polar molecule, and this cluster of molecule in which the solvent positive side is clubbed with, is attracted towards the negative sign of organic molecule, while positive side of polar solvent is clubbed by negative side of organic molecule. So this cluster is known as missile. When these missiles are clubbed together, because these are having very low concentration of solvent. So when missiles are formed and the solvent concentration is low, a structure can be obtained which is known as lyotropic liquid crystal. So here the important point is this, that it is having low solvent concentration. Lyotropic liquid crystals are those crystals which have a tendency to form soap-like missile, but when these missile get cluster, when these missiles formed cluster, it is known as lyotropic liquid crystal. So example of this is sodium laurate. Sodium laurate can be obtained in liquid crystal form when dissolved with suitable water solvent. Now coming to the next point of this lecture, that is application of liquid crystal. There are two main applications of liquid crystal. One is liquid crystal display, another one is thermography. In liquid crystal display, a thin film of liquid crystal at room temperature is sandwiched between two transparent electrodes. a cell is sealed to eliminate O2 and moisture so that the oxygen can be eliminated. And when no electric field is applied, the cell is transparent. But on applying electric field, it becomes opaque and blocks the light. So here we can say in this display system, it works on blocking the light principle rather than the reflecting the light principle. In this application, we are actually using pneumatic type of liquid crystal. And as you remember, must have remembered that pneumatic liquid crystals are those liquid crystals which get aligned in the presence of electric or magnetic field. So when we apply electric field, the molecules get aligned themselves in a manner, it is having position order now, and they block the light. They block the light. So liquid crystal display panel actually works on blocking the light principle rather than the reflecting the light principle. This principle can be used in digital or alphanumeric displays, signal display and large area picture screens. So you can observe so many liquid crystal display panel in various places. So this is the whole principle. The combination of polarizer, then we have electrode, and then we have reflector. When light is electricity is applied, then the light gets blocked and a dark surface is obtained. This dark surface is actually responsible for blocking the light. This dark surface, it means it blocks the light, and due to blocking of light, we can observe the crystal display system. That's why we are saying that it works on blocking the light principle rather than the reflecting the light principle. Next one is thermography. Here cholesteric liquid crystals are used. As we all know that in cholesteric liquid crystals, on increasing temperature, the pitch length decreases. Pitch length decreases. Pitch length decreases. And when pitch length decreases, it means the reflection of light changes. When pitch length decreases, the reflection of light completely changes. Due to this difference in reflection of light, a different color can be observed, a different color can be seen. This phenomena of cholesteric liquid crystal can be used for thermography of human skin. As we all know, where the effective area is there, in case of tumor, more heat is generated, temperature is higher. So when the same cholesteric liquid crystal comes at that tumor area, at that effective area, the pitch length changes, which decreases and appears in a different color. The part of skin or the part of body where effective area is there, where tumor is there, due to generated heat, the pitch length changes, the temperature increases, the pitch length changes, and it can be observed, it can be seen in a different color. So we can detect tumor in body with the help of cholesteric liquid crystal. Also, it is applicable in thermal mapping in solid state electronic devices to locate fault. So wherever fault is there, again the same principle occurs. Temperature rises, pitch length decreases, and it can show a different color can be obtained. Surface thermography, it is used in surface thermography in aerodynamic testing. So in thermography, liquid crystal are widely used. Some other application of industrial liquid crystals are surface thermometry, thermochromic behavior of chiral pneumatic liquid crystal, which is again known as cholesteric liquid crystals. And one more is switchable light panel, liquid crystal droplets dispersed in a polymer film whose optical property change under the action of an electric field. So when these droplets are dispersed over a polymer film, this polymer film can change color with light effect. These can be used, in the formation of windows which are known as smart windows, which works on switchable, which is known as switchable light panels, and which works on pneumatic liquid crystal type of system. Next application of liquid crystal is some aromatic polyamide from lyotropic liquid phase when dissolved in suitable solvent can be obtained. When these fibers are spun with liquid crystal solution, the molecule will have additional ordering in an alignment. As we all know, Kevlar is a very strong polymer and it is used in the formation of stable substances such as helmet, bulletproof vest, and when it is mixed with liquid crystals, which is also an elongated organic molecule, when it is mixed with Kevlar, the strength of this fiber get enhanced. So, whenever the aromatic polyamides like Kevlar mixed with lyotropic liquid crystal, their strength can be enhanced. So, higher strength polymer can be obtained out of this application. So, here these are the applications of liquid crystals. So, these are the applications of liquid crystals. So, we have studied in this lecture what is liquid crystal, what are liquid crystals, then classification of liquid crystal and some applications of liquid crystal. Thank you so much.